How do you do, ladies and gentlemen, and boys and girls and people, and teachers, and especially mothers and fathers, especially everybody who should know more about how nature behaves. And I am emboldened to remind you, physics is my business, but with some license we explore other matters, such as the fruit on a growing plant, a caterpillar in locomotion. So you see, all the world is our business for study. We are coming back to the case of the ball and the ring, where the ball does not pass through the ring. But I am also diverted. Remember, we are talking about heat and temperature. I have before me a hot cup of tea, or perhaps a cup of hot tea. You see, where the adjective goes is very essential. Now, to show you how amazing and complicated the physics, I'm going to take a spoonful of that tea. Excuse me. Some physics there. It gravitated down the wrong channel. All physics. I took a spoonful of that tea, and its temperature was so much, and I felt the thermal effects on my lips and tongue so much. Now I'm going to take the tea from the cup directly. Oh, same temperature, but much more heat energy. So you see, we're investigating heat and temperature again. Same temperature, but more heat energy. Therefore, more cooking effect on my lips and tongue. Let me now go to the ball and ring. Ball does not go through. I'm heating the ring. Oh, ho, look at here. I see at once that the ring is wetted a little. It looks wet. Hard to see it with the camera, but I assert it looked wet. Where did that wetness arise? Answer, water in the flame. Who'd have thunk it? That thunk is the past pluperfect subjunctive of the verb to think. You see how I murder the language. So I'm heating the ring. What's going to happen? The ring will get bigger, the hole will get bigger. What allows me to say that? Answer, this ring is brass. 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 It has a positive coefficient of expansion, Greek letter alpha, meaning that when its temperature is raised, it expands. So this ring is getting bigger. Question, are there some things that have a negative alpha? Sorry, I made that negative. Yes, there are. Suggestion, go to a handbook of the properties of things and seek out those which have negative alphas. I can't think of one right quick. Maybe carbon. Not sure of that. But anyway, I'm heating the ring. Somebody says, why don't you get on with the experiment, Professor? Because there are lots of things to say about lots of things. Now, the temperature of the ring has been raised, the ring has gotten bigger, the hole has gotten bigger, the ball has remained at room temperature. Now it goes through. Now I'm going to heat the ball. The ring is cooling down, as we say. I'm heating the ball, and as you expect, I will not be able to extricate it. Now, mark you, I shall have to add much more heat energy to the ball than I did to the ring, much more heat energy, because it has larger mass and will need more thermal energy to expand. Oh, I just about made it. Question, what happened to the ring? What happened to the hole? It got bigger. This we now know. Now we ask, do you understand what happened? To discover that, I do another wonderful adventure. Another wonderful adventure. Consider this metal plate. Happens to be rectangular with a round, a circular hole in it. Metal plate, circular hole. It is of such thickness, and it too has a positive alpha. I guess it is galvanized iron. Whoa, now. a question arises. What do we mean by galvanized? And is this galvanized iron or is it steel? And I'm prepared to tell you that it is falsely named, because galvanized iron is indeed steel that has been galvanized. And look what galvanized leads me to speak about. Luigi Galvani, my Italian friend who played with frogs' legs, dissecting frogs, happened to hang the leg of a frog on an iron fence and saw it twitch, and thus was given to consider what he called animal electricity. Animal electricity. His colleague and compatriot, Alessandro Volta, said, "Oh, you are mad, Luigi, you are mad. It is not that." And so we have voltage, volt, the voltaic cell, battery to run your car. Notice how much history bears on two names. Anyway, we have a metal plate. It has a positive alpha. It has a hole. We will have to now imagine this process, because I don't want to wait for the execution of it. We will imagine that I put this plate in the oven of my stove. I have put the plate in the oven. I have put the plate in the oven. Somebody says, this man is mad. No, no. To live with me happily, you must have imagination abundantly, and then we can be very happy. So the plate resides in the oven, and it's heating up and heating up. Question: what happens to the hole in the plate? Or let me take another plate. Here is a circular plate, and this circular plate has a teeny-weensy hole. Hardly see through it. And here is a square plate. Mr. Anderson, will you come up, please? Will you assert that there is a hole so tiny, like putting a needle through a camel or something?
Yes.
Is there a hole?
About a quarter of a millimeter.
A quarter, or smaller than that, Anderson. Thank you. You see what I want? I want evidence that there is a tiny hole. So I am reminded of our beloved friend Blaise Pascal, who wanted to see what happened to a barometer, mercury in glass, when he went with it to a high mountain. So he invited his brother-in-law, Monsieur Perrier, to go to a mountain. Oh, the name escapes me. Auvergne, in Auvergne. Yeah, de Petit Dôme in Auvergne, to go with a mercury in glass barometer and see as he climbed the mountain what change would be in the mercury level. And what did Monsieur Perrier do? He took along with him 12 men of the cloth, 12 priests, to assert to the truth of his findings. So you see, to assert to the truth that there is a teeny-weensy hole, I had my priest, Anderson, attest to the same. Now I have put this plate in the oven. What happens? If you understood the ball and the ring, you understand what happens here. Now, out of the charity of my wounded heart, I will tell you. There are only three things can happen to this hole. One, it stays put. It stays put. Two, it gets bigger. Three, it gets smaller. Now, I know what you are thinking. Will you not tell us, Professor, what the hole does? No, not this time. I'm going to let you suffer with it until we meet again. So some of you will think the hole does nothing. Some will say it gets bigger. Some will say it gets smaller. And my philosophy of instruction with my own students is as follows. Those of you who think one thing should try to prove that you are right to the others, and conversely. And thus you learn to think, which is our essential ingredient of life and my ambition. And I thank you for watching.